right, here we go. Okay, we are live. And let me bring up the music. Hey guys, what's going on? Oh yeah. Hey there guys, what's happening? We are doing a different stream tonight. What's different, of course, is that we are doing, as you can see with the all sky, we are actually doing a view, that is to say, a Perseid meteor shower stream. The meteors are going to be right over there in this area right here. All right, and so that's where they're going to be, right there. And that'll be kind of cool. We can see a few in the all sky, but we're also going to be looking at our live view, which is this view. I know it doesn't look like much right here, but we can actually, you'll see meteors come blazing through here pretty brightly, which is really cool. And we can also take photos. I'll give you an example. Here's a 6-second photo at 8,000 of the scene. And you'll see what we're looking at. So here you go. You can see we have Cassiopeia right here, the W of Cassiopeia. All right. We have down here, we have Pegasus, and we'll have the Andromeda Galaxy somewhere before we know it. And which is right there, I think. And we're going to be looking in this region here the entire night. That we're going to be streaming. And if you want to know where the meteors are, oh, that wasn't what I wanted. I have to, it changed my grid on me. Let me just change the grid to what I want it to be. 3 by 3, okay, and we're going to do, I'll change something here. Let me just get in here. There we go. Color is going to be a nice deep red, and we're going to change it to 2 by 2. All right, so now let me just move these out of the way. Okay, so now what this is our grid. I'm trying to, I don't know why I can't move them now. I was moving them before. It's not working. Let's try some here. Just trying to get the grid worked out just a sec. Okay. Maybe this.
Yeah. Doing the Z1 to Z6 then?
Yeah. So I gotta just move these up. Just get the Z1 to Z6 shapes going. Perseids are gonna be fun tonight. So we'll have a lot of fun.
You have a Z1 to Z9 going on.
What's that?
I said you have a Z1 to Z9 going on.
Yes, I do. 1, 2, 3, 4, 5, 6, 7, 8, 9. Of course, I'm in the way here of this guy, so I can always move myself out of the way. But I can also minimize myself a little bit more, make myself tiny.
Hi guys, I'm over here.
All right.
Hey, what happened? Hey, this might be a good look for me.
Remember that? What movie was that from? This might be a good look for me. Remember that, Daryl?
No, I don't offhand.
Okay, the movie starred Michael Keaton.
Oh, Beetlejuice?
You got it, Beetlejuice. Yep. Hello, guys. I want to say hi to everybody out there. We got Voodoo Paps and Gina is here. Hello, Gina. We have Greggy out here, and Daisy and Zoe, Dalai, C&D Boy, and Lolita. Nice to see you. Justin T. Nice to see you guys. And we are just looking at the sky. It's a live view of the sky right now. And you can just barely see Cassiopeia over here. If you want to see what we're actually looking at, I'll just take a 6-second photo and show you what we're looking at. And you'll get it right there. There you go. So this is right here. This is Cassiopeia. There's the W, 1, 2, 3, 4. Okay, there's the double cluster and Perseids. The Perseids are going to be emanating from right around here. Well, look, there's a little satellite that we're seeing right there. That's kind of neat.
The head of Perseus peeking over that tree in that last image you just showed.
Right here, you mean?
3 stars in the triangle? Yeah, that's his magic helmet.
Yep.
The radiant point is just to the left of that.
Yep. So that's what we're looking at. I could move the camera a little bit toward that area a little bit more, but it's going to be raising this way, so I'm kind of, you know, and they don't always stay pointing at the radiant. They will come. They'll come from many directions. All right, so I'm going to try another methodology, not tonight, but another methodology. Since we are primarily a deep sky observatory, setting up a camera on a tripod and just having it aiming at the sky is cool, but it may not give us exactly what we need. And what I want to do is be able to show you that. Okay, these are going to be our zones: 1, 2, 3, 4, 5, 6, 7, 8, 9. We can actually change this a little bit and kind of even it out more, like that. And those will be our zones for if you see any meteors, you just announce which zone you saw them in. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We have a plane down there, which you can't really see. It's down below here. Hello there, Trish Williams. Hello there, Marianne Robb. Nice to see you here. Tara, nice to see you here. And Governor, what's happening, man? Tim F., welcome as always. James Dugan from Down Under, how's it going? I was talking to my friend who was down in Australia for, 3 months while his wife was working there. And well, you know, all he had to do all day was just drive around and see the sights. Being a professional photographer, that was kind of like a dream come true for him. Very cool. Let's take another 6-second photo and see if we can see any more satellites. There's the plane we were talking about right there. Okay, but no satellites yet. We also have an all-sky camera tonight, and the all-sky will show us all manner of things. I will actually just I'm going to do a little adjustment here to the values to make it a little better. There we go. You can see the Milky Way going right there through the all-sky. Now the all-sky camera is taking a picture every 30 seconds, so it's never not exposing. It's always exposing the picture. So if the next one comes in and there's a streak on there, it can either be a satellite or a meteor, but we'll know the difference. And so this is now taking pictures all night long, and it will record these photos all night long and into the morning. So we will have a nice record of every single Perseid that streaks across the sky from this camera. And that's very cool. This is, you can see the telescope is in the dome. We're not using a telescope tonight. It's a nice night. I should be, but I'm not. And here is the dome, here is the camera set up over there. And then it's aiming into this direction. Here's Cassiopeia down here. Tink, 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 tink. All right. And as the night goes on, you'll see the sky moving a little bit. And if you don't see a streak in here, we didn't see a meteor. So it's kind of cool to actually just watch the all sky.
Is this the same camera that you normally have on the back of the telescope?
On the back of the telescope, no. This is the all sky camera that sits up.
Excuse me. No, I'm sorry. I meant the other view you have.
No. That's actually the telescope's main camera that I put onto the tripod.
Yeah.
Yeah, and
Introduce me, Mark.
oh my gosh, I am so sorry. Everybody, you know Daryl Mason, and he is here with us tonight. Daryl, of course, is a wonderful co-host with me here on SkyTour LiveStream, along with Amanda, who isn't here with us at the moment. Trying to see if she's around. We'll just check to see, because that's always good to see if she's around. Not yet. But that's all there is to it. So, not here yet. But if she comes in, if she wants to join, she's more than welcome to. So this is our live view. You can see Cassiopeia over here. Yes, it's a little dark, but that's because we are trying to capture. We're trying to capture some beautiful objects tonight, and I want them to show some contrast. But what I'm going to do is just to help out a little bit. I'm going to do something like a little bit of this. Okay, I'm going to make it a little bit brighter in a processor. Yeah, sorry, Daryl. I didn't mean to not introduce you. I don't know why I didn't.
No worries. You'll miss me when I'm gone.
Well, of that, there's no doubt. Of that, there's no doubt. Okay, so. So over here, you see an airplane going over here. Okay, let's have some fun. Let's just take a 6-second shot of that. And we'll see a nice streak. This is an aircraft heading toward Bradley International Airport. You can see that. And there's another one there that's up high. Bradley is kind of in that direction, so he's coming in. They usually come in from behind us, over us like this, and they'll curl around and then head into Bradley. This is the view that we have typically. Let's go back to the live view. For those just joining us, we have some zones, okay, that you can use to identify the meteor. Oops, sorry. Let me just get that aligned better. I don't know what happened there. So these are the zones. It goes across the top 1, 2, 3, and 4, 5, 6, 7, 8, 9. And the zones are where the meteors are going to be seen. I would think that the radiant, actually, where they are right now, is just behind my head back here. Okay, so it's right around there. That's the radiant. That is to say, the supposed origin point. But they can appear anywhere in the view here, and outside the view as well. So that's just the way meteor showers work. And what we want to do is watch for the color of these things. The meteor's color tells us a little something. Usually they're yellow, and they might leave a trail. And if they leave a trail, then we can take a time exposure of the trail, have this beautiful meteor trail photo that you can have for free, of course, and share with anybody. These trails, of course, are the upper atmospheric trails left behind by the hot ablated, that is burned off material that has left smoke behind as it is vaporized. And you'll see that stuff being You'll see that stuff behind the meteor trains, or behind the meteors as they burn up. Typically, right? And not all meteors leave a trail behind them, but they all leave a very imperceptible amount. And this dust makes itself evident on the ground overnight. You can actually tell you a little thing you can do, and it's not as effective currently because of the fact that there's a lot of pollution and stuff in the air. But what you could do is you lay a sheet in the backyard, and I think Daryl, you've talked about this as well. And you lay the sheet in the backyard, and when you do that, you go in and go to bed. And in the morning, you come out with a magnet. And what you can do to find iron-based meteoritic particles is to just run that magnet over the sheet. The particles that stick to the magnet may very well have come from space. So that's kind of a cool thing to do. And for Daisy and Zoe who are listening, you might want to tell Lane to try that. Lane is a young lady who is interested in this stuff. And Daisy and Zoe often bring Lane to the streams. So try that one. Now, it's not guaranteed that it'll all be meteoritic dust, but it's a possibility, and that's kind of cool as well. I'm going to take a 6-second exposure here to see if we got any satellites in the view at the moment. Some might be very faint, and we do not. We just have a little cloud. We won't actually miss any meteors even when I go to take the pictures, because we have this guy, the all-sky camera going, and so it's got the entire view, and it won't miss anything. Now in this view, you can see Cassiopeia way down here. Okay, here it is, 1, 2, 3, 4, 5. Okay, and the radiant where it's starting from is here. We're early in the evening now, so as the evening wears on, this will get higher in the sky. And these are what are called circumpolar constellations. So they go around the North Pole, which is right here. This is the North Star there. And they'll go around this. So it's going to go in a circle around this great big circle. All right. So that said, we'll just sit and wait for the evening to unfold before us. And like I said, we won't miss a single meteor because this takes a 30-second shot. And if a meteor comes through in that time, it's going to be caught. And then as soon as that shot is done, the next one comes in as well. It starts.
Does it save the previous image for review?
Absolutely. In fact, at the end of the night, what I can do, and I will do, is I make a movie out of it. So we can watch the stars moving across the sky, and then we can actually see the meteors come through. And then we can actually gauge the gradients and figure out where they are actually coming from.
Cool.
Yeah, this is the all-sky camera for the Arizona telescope. And I mean, again, this is not clouds. This is the Milky Way here. So even where we are, we do have some pretty nice Milky Way here. Even on a night like tonight, which is going to be clouded up eventually. Okay, looks like my outside lights went on. Hope it's not the bear. We have a mountain lion in the neighborhood too, so every time I go out there, I got to be really careful. All right.
Take a shotgun with you.
Yeah, my shotgun is out in Arizona.
Oh.
It's at the Gilbert Police Station in Lockup. I think that's right, isn't it, Marianne? I think she's here. Marianne will tell me. So here's a live view. Again, we got our grids if we want them to identify where the meteor is. Just remember 1, 2, 3, 4, 5, 6, 7, 8, 9. No, Daisy and Zoe, any night, actually, because the Earth gains thousands of pounds of dust overnight, and maybe more. Actually, several tons over the course of a year. I think they what did they say? How many millions of tons the Earth accumulates in a year? So you can do that. Lay out the sheet tonight, even if you like, or lay it out a month from now. And in the morning, you go out with a magnet and you go across it very carefully, and you may not even see it. So you have to really, be careful about it. The best thing is a bar magnet. If you got a bar magnet that's about like this big, see my little image down the lower left here, about that big, maybe 6 to 10 inches in size. They sell these little bar magnets, and you just drag it across the sheet very carefully, and you look at it very carefully, and you wipe whatever's on it down into a little Tupperware container, and then you actually will be able to see if the iron particles that came from space are in there.
What some people do is they put a catch pan at the bottom of their gutter drain and put a magnet in that.
There you go.
And just periodically go out and check the magnet, and if you've got iron particles, it's very likely it's meteoritic in origin.
That's right. You mentioned that before, Daryl. Really good comment there. We can do that. So if you got a gutter, just basically lay the magnet inside the bottom of the gutter, and you got to wait for it to rain, of course. Or if you're impatient, you can turn the hose on and spray your roof down. Actually, that'd really be the best thing, actually, to just spray down the part of the roof that's associated with that gutter, then move a magnet to the other gutter and spray down that roof part that's associated with the gutter, with that downspout, I mean. And there you go. Now you can actually collect all of it. Haha. Pretty cool.
Mark, Tom asked you a question.
Oh, you did? What did you ask?
Are these meteors from the comet dust? If you like, I can field the questions if you want. But
sure.
He addressed it to you.
No, it's okay. Go for it, Daryl. This you can tell him about the comet that is responsible for these.
Tom, yes. Comet called Swift-Tuttle produces the annual meteor showers, debris from the comet's previous orbits. Swift-Tuttle orbits something like every 133 years, if I remember right. Last time it came through was back in the early 90s. And that's one of the annual star programs I did for the state parks here, was the Perseids. And one year, 92, early 90s, was actually a year that the comet came back and sort of reseeded its orbit. And everybody had big hopes of that being a banner year for meteors. Frankly, it's been so long now, I don't remember if it turned out to be that way or not.
Mm-hmm.
But it did reseed the orbit. Comet Swift-Tuttle, actually I was reading this afternoon about it. Swift-Tuttle is one of the largest comet bodies of all. It's quite large. I forget how big now offhand. 16 kilometers or bigger, or something like that. And it's in an 11-to-1 orbital resonance with the planet Jupiter, which, Jupiter being the shepherd of the solar system of sorts, it affects a lot of other bodies moving through, like comets. And I think they said there's some chance that it could affect the comet's orbit so much that there is like a small chance that the comet could actually hit Earth in 2126 or something like that. So we have that to look forward to. I won't be around to see it.
How do you know?
Just a roll of the dice. I really doubt it. I mean, that's 94 years from now.
Yeah.
I'm darn near decrepit now. I'd be a slobbering idiot in a wheelchair by then.
Well, no. You'll maybe you'll come back again, and you'll be you'll be a middle-aged man the next time it comes through, or maybe an old man next time it comes through.
We'll see.
Yeah.
I'm not going to hold my breath.
No, I don't think that's a good idea. You can see some clouds down here. Here's a plane starting to make its way through. You can see the twinkling of the stars. That they're twinkling because there's some kind of interference in the sky, probably a light clouds. Meteors can be seen through light clouds very easily, and it's actually kind of cool. So I have no problem with that. So we'll see if we can stick around for that long. And every now and then I periodically check the all sky camera so we can see if there's any streaks. Okay.
I went out last night. We're summer monsoon here still. Clouds up every afternoon. Might or might not rain.
Okay.
But it finally, for a change, it cleared after sunset and had a beautiful night last night.
Mm-hmm.
Then it clouded up late.
Okay, this is our...
Really pretty sky, but I did not see any Perseids last night. Didn't see any meteors at all.
Okay. There's Cassiopeia, the W of Cassiopeia. Okay. The Great Square of Pegasus is down here. We're going to have Andromeda coming up soon. And this is the head of Perseus right here that Daryl was telling us about earlier. This is basically, the radiant is, I think, right about here, isn't it?
It's just to the left of that triangle.
So about here then?
Maybe a little higher.
Okay.
That general area, yeah.
Yeah.
And
Okay.
actually, it looks Andromeda is up right now.
Yes, it is.
If you see two curved rows of 4 stars to the right of Perseus, kind of a horn shape coming together with that bright star over on the right side, that is Andromeda.
This is Alpharats, I think.
Yep. And that's the Great Square of Pegasus just to the right of that.
Yeah, and here's the Andromeda Galaxy right there. You see it?
Yep.
Yeah, but we can see it better. Yeah, zooming in, I notice there I'm going to have to go refocus a little bit. Cameras have that problem. Temperature changes their focus now and then. I'll say though...
You can actually see 3 of the 4 stars of the Great Square of Pegasus over there on the right.
Yeah, we got 1, 2... is that
3.
that one there? So 1, 2, 3, and the 4th one's just out of the view. Yeah. And then Andromeda starts here and goes over here. And if you go the first star off of, this is Alpharats, the upper left corner of the square, when you're looking at it normally. First star, the second star, and you go up to this star, and then a little more, and there's the Andromeda Galaxy. Visible to your naked eye. Quite cool.
If
Yeah.
you ever saw the old Ray Harryhausen movie, Clash of the Titans, I've never watched the new one, the one where the guy says release the Kraken. But the old one,
Release
I
the
think
Kraken.
Harry Hamlin played Perseus, I think. That's basically the story out of Greek mythology, and which is what's sort of being shown here, is Cassiopeia the queen is over on the mid-left. She's sitting on her throne. Perseus is down below her, and his wannabe girlfriend Andromeda is just to his right, and Pegasus, the flying horse. To me, it always looked like she's doing a handspring off his back, but I'd have to go back and look at the mythological figures in the sky charts. But that's most of the characters in the story right there. Cassiopeia was boasting about her daughter's beauty, and for punishment, I forget which god, might have been Poseidon, he declared that Andromeda had to be chained to a rock to be fed to Cetus, the sea monster, which is just out of view to the lower right there, I guess. And to save Andromeda, Perseus, he received several gifts from the god. He received his magic helmet, which that triangle is there. If I remember right, it made him invisible. And a shield and a sword, I think. And he went and slayed the Gorgon, the Medusa, and whacked off the Gorgon's head, and then he rode Pegasus to save Andromeda, who was about to be eaten by the sea monster. He showed the Medusa's head to the sea monster and turned it to stone and saved his girlfriend. That's the Greek myth for you. Or the Hollywood myth, however you want to put it.
Very cool.
A little later in the evening, when Perseus is up higher, you will see a bright star to the lower right of that magic helmet, that triangle of stars. And that's a star called Algol, the demon star. I think it means the ghoul, or the demon in Arabic. Algol is an eclipsing binary, and the ancients saw that and knew it. And that's why it's called the demon star, I guess. It sort of brightens and dims on a regular basis, and as one star eclipses the other. And that is the Medusa's head in his left hand that he's, pulling out of a sack on his waist, I think, and getting ready to turn the Gorgon to stone.
Mm-hmm. Yes, you have to love the mythology, there's sort of a logical connection to almost every constellation in the sky, or something associated with our culture that's been immortalized in the sky.
Yep. They didn't have TV back then, so they put their stories in the sky instead.
That's correct.
Played connect the dots with the star patterns they saw, and
yeah,
they put their myths in the sky.
Yeah, that's true. Very true. The last Perseids, were you with us, Daryl, when we saw that beautiful Perseid that actually kind of brightened a huge amount, sort of like, actually it was about like right here in the sky, and it actually got so bright that it flared and then it continued on before it faded out.
Last year?
I think it was.
I have a hard time remembering what I had for dinner last night.
Oh, you had fish, remember? Oh.
I
don't
had
know.
fish tonight.
Oh, okay.
If I had seen it in person, I'd probably be more likely to remember.
Yeah.
I remember a couple of Perseids from last year that I saw out in my yard.
Okay.
One was red and white, and I remember other notable meteors from the past.
Okay.
Many from the Leonid showers back in the late 1990s and the year 2000, I guess it was.
Okay. You might remember the Omega Nebula that we took pictures of the other night. Folks, if you were with us, kind of looks like this, in a sense. Well, if we were any closer to the Omega Nebula than we took a picture of it, it would look like this in our sky, perhaps. So this could very likely have been a nebula in our sky had we been closer to those star-forming regions. Just kind of a cool thing. Now, did Bill see any Perseids last night?
A few.
Yeah?
Yeah, not a lot.
Well,
there were a couple of notable ones. One was 302 and 50 seconds, I think. And there was one other bright one. There were quite a few dim ones. Quite a few, but a good number of dimmer ones. And there were several bright, fairly bright non-Perseid sporadic meteors, are called. They were moving the wrong direction, so you can tell they were not Perseid.
right. You get them all night anyway.
I wound up leaving his stream about 1:30 my time last night. Went to bed.
Okay.
I'm not used to staying up that late.
Mhm.
I had to crash. I assume he went till first light of dawn.
I think you did 5 o'clock or 5:30.
Yeah,
I think so.
that was the plan.
Yeah. I'm not sure what he's going to be, how long he's going to be going tonight.
Oh, if the weather holds, I'm sure he'll go all night.
Well, we do have clouds that are supposed to get in the way, unfortunately. Yeah. And that...
He'll probably, anyway, it's an excuse to stay up, and
Yeah.
I think he wanted to play Family Feud, so
Mm.
wouldn't be surprised.
Oh, see, I'm looking at his stream now. He has clouds too at the moment.
Wow.
So, that's unfortunate. Which means that he has clouds. We're gonna have clouds. We got a plane.
Breaks.
Yeah. Let's do, let's say 8 seconds. 10 seconds at 4,000, be about the same brightness as the last one, and we'll catch the plane coming through. Let's do the all sky here. There's that plane we're talking about right there. Okay, and then we have this. And there it is. That's how planes look on film, folks, and film on when they're captured by a camera. There's constant lights that are on. Okay, and then you have these strobes, which are these punctuated dots. That's how they look. And you think, well, most of you are saying, well, I already know that. Why tell me that? Well, the only reason is because of the fact that people have, in fact, sent me those photos, said, these are UFOs. I caught it on film. I don't know what it is. And they don't realize they're planes, because what's happened is their camera has captured an ordinary object in an extraordinary way, which is what I like to tell people. Can happen.
I know a guy up in the high country, actually not too far from here. He's a former president of the local astronomy club. He runs an all-sky camera like yours at his observatory up there.
Mm-hmm.
It's in a little tiny burg up in the mountains called Guppy, Colorado, which is the whole southwest of here.
Yeah.
Yeah, he's a member of the Fireball Network.
Fireball Network?
I don't remember if that's the official name or not. Yeah.
Okay.
He runs a camera every night, every clear night at least, and he records fireballs.
Okay.
His setup looks much like yours.
Okay. I'm gonna work as well as tomorrow. I'm gonna start working on a new aspect to handle the video coming from the camera, because the camera's capability is far beyond what we're seeing on the screen here, and I'm going to try and implement the full quality of that capability, and so I think I'll be doing that for sure.
Daisy, what's the difference between a meteor and a fireball? Fireball is a meteor. It's a very bright meteor. Fireballs have the technical name of a bolide.
If they make noise.
I'm sorry?
If they make noise. The technical definition of the bolides was one that actually makes noise that you can hear, if I recall. Do you remember that?
I would dispute that. It's extremely bright. It's brighter than some given magnitude. I forget what. I've never heard a meteor make noise.
Oh, I have.
I've seen some spectacular fireballs in the past. I've missed some too. Back 99, I think it was, the astronomy club was having a meteor party for the Leonids out about 35 miles northwest of town, or northeast of town here, out at a ranch out in the country. And Well, it was November and it was getting cold at night, and everybody was in lawn chairs or chase lounges, wrapped up in sleeping bags. And I had laid there since midnight when the radiant rose from the Leonids. And we saw tons of cool meteors that night, and I had gotten so cold and stiff that I had to get up out of that chase lounge. And I had no more than rolled out of that lounge, and I was on my hands and knees facing the ground. Then the best meteor of the night, a fireball, went off directly behind my head. I'm the only one in the group that didn't get hit, but it lit up the landscape all around like a flashbulb did. And everybody goes, ooh, wow. And I knew I'd missed it and turned around. It was gone, of course. But interestingly, it had left a smoke trail in the sky.
Yep.
And we watched that smoke trail sit there and turn into curlicues up in the upper level winds for like 10 or 15 minutes.
Mm-hmm.
It was really something.
Oh, yeah. We had, I was up in Maine. No, I'm sorry. I was up just a couple towns over from here. And we had one of these August Perseids come through. And as it came through, this was after midnight, it came across the sky slowly. I'll use my mouse to kind of indicate how fast it kind of went. So it went from right to left. It went like this. It went like about this speed. I had time to hand the binoculars to my cousin Scott, and he had time to look at it with binoculars and hand me back the binoculars. It was like an earth grazer, and it just went from horizon to horizon. And then it broke up into 3 distinct red hot pieces that you could see very clearly. And then it was like a couple minutes later you heard, I mean, you could hear that noise. And it came right from that area in the sky. And that's the second time we heard an explosion. The first time I was up in, the second time was up in Maine and looking at these meteors, and one came through, same thing. This one moving a little faster, but then when it broke up into a couple of red hot fragments. You clearly see several fragments, two red fragments, I should say. And then a little while later, you heard this explosion that finally got to you. Just incredible. When I saw it breaking up, I actually thought, I said, okay, we got to be quiet now and listen for the sound. And we figured it was going to take whatever the timing was. We had figured out the timing for approximate distance. And we waited 30 seconds either side of that, or I'm sorry, like 15 seconds either side of that. And then it was just like, it was beautiful. It was a multi-stage boom. It was like a boom, boom, boom. It's just so good.
Right.
Really nice.
The word bolide comes from the word bolus, which means ball-shaped.
Yeah.
Hence fireball.
Mm-hmm.
A bunch of friends and I, the most incredible fireball I ever saw. I was back in Missouri on vacation visiting in a summer when the second Star Wars movie just came out.
Okay.
And we all went to see it at the theater that night. And after the movie, this was summertime, we were sitting out in this one couple's backyard,
mm-hmm.
and it was a beautiful, clear summer night back in Missouri. One guy stood up at the south edge of the circle of people sitting in the dark, and he made this grand gesture with his arms up in, over his head to either side. And he goes, "Boy, what I really liked about the movie," and he was shaking his hands. And it was like he had conjured this thing up. This tremendous fireball came out of the east. And, I mean, it was huge in the sky, and it was breaking up into hundreds of fragments. It was moving east to west. So at least we knew it was very unlikely to be, anything man-made.
Yeah.
And it just exploded into hundreds of pieces. Never heard a thing, but it was A couple of women had gone inside to get drinks for people, and again, everybody in the crowd saw it except for the guy who made the grand gesture. It happened right behind him, and he goes, "Boy, what I really liked about the movie," and he shook his hands, and this thing went off right above and behind him, and everybody goes, "Ooh!"
Yeah.
The women knew instantly. The ones who had gone inside, they heard the ooh and the
Yeah.
ah, and they came running outside. What did we miss? What did we miss? That's the most tremendous meteor I ever saw. And it was huge too. I mean, it looked like like a big firework, like a mortar going off behind him.
Yeah.
Hundreds of fragments.
Amazing. Let's go check the all sky while we're here and see if we have anything that we captured there yet. Nope, not yet. Not yet. We'll do a 10-second shot here at 4,000 just to see what it's looking like here. Okay. For those of you here, this is the Milky Way right there. Yep. Okay, let's go look at our view. Oh, there we go. Look at that. We caught a satellite. You see that?
Back in 1998, I think it was. The Astronomy Club was having a star party at that same location at that ranch northeast of town here.
Mm-hmm.
But I was on my own that night. I had decided to travel way out to the very southeast corner of El Paso County, Colorado. I had been doing a lot of explorations out there looking for dark sky sites for the club. And I was bombing down this gravel road out in the middle of nowhere. And right at midnight, the sickle of Leo, it looks like a big backward question mark about the size of your hand at arm's length.
Yep.
The sickle rose right about midnight, and Regulus at the bottom, which bright star Regulus in Leo, it looks like the period at the bottom of the question mark. Regulus had just broken the horizon. I'm still driving, and the radiant for the Leonids is right inside the sickle, just above Regulus a little ways. And meteors were coming out of the radiant, coming out of the sickle, that looked just like skyrockets, or looked like Roman candles, the way that it shoots up those balls of fire. And just on a pretty steady pace, just pew, pew, pew. These Roman candles were coming out of the sickle. And, well, I stopped so I could watch, and I decided that was as far as I was going to go. Got another satellite going right under the middle star in Cassiopeia there. And there were some clouds, but it was mostly clear. And it was these mortars going off, or Roman candles, were so bright, and they were all very colorful. Some of them were going behind the clouds, and they were so bright you could see them, behind the clouds, through the clouds. And it was tremendous. I just sat there in the dark and tried to take it in.
Yeah.
And a heck of a show. And this was a couple of years before the big meteor storm.
Mm-hmm. There's a satellite right there.
Yeah.
And now we're starting to get some clouds too, I guess. All right, let's just go back and we'll check the live, and we'll go to... I'm going to go to the all sky. We have this here. Might be a plane, but it might be a satellite. I'm not sure. It's too much into this sky glow in that region of the sky. We'll see. We'll find out. So that's pretty cool, Daryl. I mean, I think the finest meteor I've ever seen is the one that broke up into 3 parts that I could distinctly see, and then hear the sound of the explosion from it. That was just, you can't beat that, you know? Absolutely beautiful. I want to say hi to Kubota Man Dan and Raz Taz and Carol Carl's here, along with D. Smith. And we have a number of people. Papa Tom is here with us now, and good to see you, Papa Tom. Bobby Burgess is here. I said hi to you already, Marianne, but I'll say hi again. Hi, Marianne. And Donald Kunzer is here. Thanks for coming out. Keisha Fowler is with us. That's nice to see you. And many of you guys, and Tara's here, many of you guys are bopping back and forth between Bill's stream and our stream. I know Bill has some clouds right now, but I don't know if that's going to change much. It's going to get worse, actually. He's got some, you know, the skies are going to get cloudy for all of us here. So we'll see what happens, you know. We'll see how far we can go. So, pretty neat. I want to welcome you guys. I think we also had someone who came in here, Bill. Yeah, there it is. It's Kubota Man Dan. Okay, you're the one that Bill sent. Kubota Man. I have a Kubota too. I have a B-21 backhoe. And if your name is Dan. Not sure if you're interested in a backhoe. I've done everything I need for it. It has only 1,000 hours. I changed all the hydraulic hoses on already. Because I bought it used, of course. And I actually used it to dig the pier holes for the observatory here. And it really looks good. And it's... I love the orange. You know. But it has a cab on it with no glass or anything. But it works really, really fine. These little diesel engines are just really powerful. You can't kill them, you know. But I'm assuming that you have your name that way because you have some Kubota knowledge. You know, so. I'm still waiting to see what we're going to have here. Hey, Mr. Dingo 57, how are you?
Tom, I have never found a meteorite to my knowledge. I have or had an interest in collecting them. I do own several, plus some tektites. Oh gosh, there's 2 great books, and the author's name escapes me at the moment. One is called Rocks from Space. The other is a Meteorite Handbook, which gets into detailing meteorites, different types and all that. And the book Rocks from Space, his name is Norton, is a really good book. It gets into the whole subject of meteorite hunting and identifying them and, you know, classifying them and all that. Talks about search ellipses and stuff, and also talks about some of the historic meteorite hunters here in the U.S. I forget his name, Nininger, something like that.
Oh yeah, you're right.
They're both excellent books.
Yeah. Hang on, I'm gonna just grab something here, Daryl. Be right back.
Sure.
Good girl. Good girl.
I have a Canyon Diablo meteorite, which is part of the impactor that formed Meteorite Crater, Barringer Crater down in Arizona. It's about as big as my fist. It's got desert varnish on it. It was out there for thousands of years after the explosion happened, of course. And I used to take the meteorites along when I would do Perseid programs in the state parks.
Very cool.
People have the strangest reactions to meteors. It's sort of a Andromeda strain thing. A lot of people are scared of them. And I was so proud of this Canyon Diablo after I got it that I let it ride around in my car for a while. And, oh, cool. I left it in the car one day in a cardboard box, and, the car got hot inside, so the meteorite got hot. And I went to a local diner for dinner, a place I used to go to a lot. And I brought it in with me. I was showing it to the waitresses at the diner counter. One of them picked it up, and of course, this thing was warm, very warm to touch.
Still radioactive.
Yeah. And they got scared of it. She dropped it on the counter. She didn't want to touch it. Thought it was radioactive or something.
It's radioactive.
Yes, Carol. Richard Norton. Thank you.
Oh, thanks, Carol. Good job. By the way, this is a 1,000-gram meteorite. It's a big iron chunk, and it's a really, really beautiful meteor. It really, if you leave it outside in the humidity, it will rust. So you definitely have to take care of meteors, especially iron ones. The iron bodies will actually rust on you. Pretty cool though, huh?
It is.
Yeah. You can't hold on to it for too long because it's radioactive and your hand will fall off. No. But what you look at, if you notice you see all these little cutouts and holes. This is when it made its way through the atmosphere. These are the parts that melted and ablated or burned away. And that's what happens with meteorites, I should actually make this just a little bigger. And
they're called eclipse.
Yeah, that's right. How'd you know that?
Because I used to, I read Norton's books. He talks about all that.
So this is the actual meteorite, okay? And you can see it's got all these beautiful little convolutions in it and stuff. The areas where the re-entry burn actually caused the burnout here of something, and it was melting and ablation. It's called ablation, ablation, and it's full of pits. I mean, for all the world, it could be an asteroid. With all these scars on it, it's really, really pretty. And it's heavy. This little guy weighs 1,000 grams. And you look up, especially because of the nature, the shape and how it looks. This is a really unique shape. And many meteorites look somewhat rounded. They've been weathered on the ground. This one was actually retrieved soon after it fell. So it didn't have a lot of time to weather on the ground. So it's pretty pristine in terms of how it looked from space. When it came from space. So that's actually kind of cool. This came from Argentina. This was from an Argentina fall. Yeah.
Golly, which one is that? The well-known meteor fall from Argentina. I can't think of the name of it. Cielo something or other?
Maybe. I have it written down.
Kenneth Cantu, yes, thumbprints, thank you. Regmaglypts, REGMA, Regmaglypts, GLYPTS, I think.
You're talking about the undulations? And undulations in the surface.
Yes.
Yeah.
Thumbprints. I said thumb holes.
That's okay.
Thumbprints.
Yeah. Kabuto Mandan asked a question. Did I find it or buy it? Well, actually, neither. Actually, this was given to me. Believe it or not. I took this in trade for doing some work for somebody. And they said, "What do you want?" And I said, "Meteorite." And they went, "That thing? You want this chunk of iron?" Okay. So yeah, I got it and got the certificate of authenticity. I know where it came from. It's actually quite a valuable little piece because of all of its many regmaglyphs. Has a lot of personality. Pull us back down here. Okay.
When we see iron meteorites, they're usually a combination of nickel and iron, and they're called nickel iron meteorites.
Right.
You can take one, and if you cut it in a flat plane across and polish it and maybe etch it, a beautiful pattern will come out, a crystalline pattern. And now I'm suddenly having a brain lock. What's it called? The Wittgenstein pattern. Really beautiful crystal structure will become evident when you cut it and polish it and etch it. And they're just stunning to see.
Yeah, they are. People make watch faces out of them.
Yeah, I have one I got. It's from the big, which one? The Gibeon meteorite in Africa.
Okay.
I was going to make a belt buckle out of it. It's that big.
Wow.
It's sort of like a cowboy style, meteorite belt buckle, and never got around to it, of course. I'm actually glad I didn't, so I didn't ruin the thing.
Yeah.
But it just has a beautiful Wittgenstein pattern on it. And
Yep.
you have to be careful once they're cut and polished. The oils in your skin and the salt and stuff in your skin, the sweat, it can cause the meteorites to start degrading.
Yep.
It's called meteorite disease.
Yeah.
Not a disease to you, just to the meteorite. It starts turning brown and junk comes out of it. Sometimes they'll fall apart if it gets bad.
Is that for the stony meteorites or the iron?
The irons. Nickel irons.
Yeah. Hey there, Ken Cantu. Nice to see you here. Amos, how are you? Amos Cardoza. And Brainius Balky. Hey, Cousin.
Yes, they are worth money. There are meteorite hunters or guys who buy and sell meteorites. I forget the guy's name now. He does or did live down in Arizona. He used to regale people with tales of his travels around the world, collecting meteorites, buying them, stealing them, trespassing, all that kind of thing. Some, like Mark's there, or that Canyon Diablo, I paid $250 for the one I have, which is about the same size as Mark's. And that's a pretty common meteorite, so it's not too expensive. Some meteorites are literally worth their weight in gold. Some are priceless.
Hmm. Look up how much of the iron meteorites are selling per gram, and this is 1,016 grams. So you can figure out what this one's worth. That is correct, Kenneth. That is Cassiopeia rising. Exactly right. That's exactly what we're seeing up here. This here is Cassiopeia. I'll just take a quick 10-second shot here to show you. Meanwhile, let's look at the all-sky, see if it's caught anything. This is our all-sky camera. It takes a picture for 30 seconds, and then right on its heels takes another picture for 30 seconds. So we don't miss a second in the sky. We have a full night sky record all night long. And at the end of the night, we'll take all these images and put them together. And if there's any meteorites, we'll see them come streaking through. Very cool. So here is the night sky right now that we're seeing right here. Let me just show it to you more clearly. So we actually have the W of Cassiopeia here. Okay. We have Pegasus over here. Okay. Look at this. What's this over here? Looks like we have... Are those two satellites or are those two aircraft? That looks really odd over there. Huh. They don't look like meteorites, though. They look like meteors. Really interesting, though. And then we have Andromeda here. And for those of you with sharp eyes, you look right here, you can see the Andromeda Galaxy. 2 million light years away. And heading our way. And the W of Cassiopeia over here, The end star here and the head of Perseus, these 3 stars right here, almost directly in between and a little bit to the left, you see this. This is the famous double cluster. And when we're using the telescope, which you can see it's in the dome here. We don't have the dome open tonight because we're doing the meteor stream. This is a camera setup we have here, and we're looking with the all sky camera here. So we're actually seeing some interesting. Yeah, look, those are satellites. Look at that. They moved, and it's a pair of satellites moving through the frame. And that's kind of cool. That's fun when we do it like this. So if we come back to our view here, they're right about here, moving through the frame. And if I do another 10-second shot, all right, at 4000 ISO, you're only seeing part of what we have for our setup during the typical SkyTour LiveStream. And I'll tell you more about that in a sec. Well, now I don't see them anymore. That's weird. Well, maybe they actually moved more in the time that we were talking. No worries. All right. Anyway, back here. This is the camera control section over here. We control the length of time that we're going to expose the sensor and the sensitivity of the sensor. And this camera goes up to 409,000 ISO, which is really, really high. And to get an idea of what that looks like, we can do we're doing 10 seconds here. But let's go down to, say, 1 second. All right. And let's go down and actually bring this up to the maximum amount that the camera can do, just to give you an idea of what 1 second like that looks like. So here we go. Okay, this is 409,000 ISO. So we say take the picture in 1 second. And that's what it looks like. It's overexposed. Okay, so you see, it looks like daytime. So the camera is very sensitive, and this is excellent for deep sky imagery and doing photos of deep sky objects. Right? So we would have to take photos at a very short time to see, in a very short time, to actually see any objects on here with any clarity, because otherwise it'd be overexposed. So right, so there is, so we've been doing, as the night wears on, we'll do this a little bit longer and longer. So 4 seconds at 5,000. And then we're just waiting for some meteors to come through. It's 10:30 right now. And so we might see a few, but most of them will occur later. And that's something that is always a sight to see.
Amos, to answer your question a little bit ago, if the radiant is above your horizon, you have the possibility of seeing shower meteors. The higher the radiant climbs in the sky, the more likely to see them. Typically after midnight is best, between midnight and dawn. At that time, Earth is facing into the direction it is orbiting around the sun, and also facing directly into the meteor stream. And there's a thing called the ZHR, the zenithal hourly rate, which is the projection of how many meteors you would see in perfect conditions with the radiant directly overhead. The Perseids ZHR is typically, I've heard it put as high as 100 to 120 an hour. Will you see 100, 120 an hour? Maybe, maybe not, but and that's if you're, in perfect conditions and you're facing up and all that, trying to take in as much sky as possible. When we orbit the sun, when we face east at local midnight, that is the direction we are moving in space. around the sun, just rising above the horizon. And when that point rises, it may not be perfectly east, but where we're facing that direction to the ecliptic plane, the plane of the Earth around the sun or all the planets, that's when it rises as a local midnight. And when that point is as close to directly overhead as possible is at sunrise. And that's when you ideally would see the most, per what Kenneth Caddy said a while ago. Night, Marianne.
Wimp. She's wimping out. That's okay. She works early.
Yeah.
When I was out there and I went for the ride along with her in the police car or the police mobile. She has a Batmobile police mobile, like a police car, Batmobile. It's really pretty interesting. I mean, she made me get up at 3 o'clock in the morning. Oh, and that's, I'm an astronomer. I'm up late. I mean, for me, that's 6 a.m. from where I was, right? Because it's 3 hours to Connecticut from there, and that's where I am. Now, when I'm actually living out there, this won't be so bad. But right now, it's enough. And when we do our streams out there, I have to shift my bio clock anyway, because we're going to be 3 hours earlier in Arizona, or 2 hours earlier in Arizona, depending on how the clocks are set in Connecticut, for instance. And for a period of time, I'll still be in Connecticut and running the observatory from here. So I am going to have to make sure that I'm taking into account that time difference.
Right.
They
don't do daylight savings time in Arizona.
No, it's 7:38 right now out there.
Yep.
And it's not even dark. So we wouldn't be starting until around 12:30 midnight. After midnight. That's starting. And if we do a typical 4-hour stream, that's 4 in the morning here. Okay. And it's late out there, but still not bad. But under those skies, I do not think I'm going to be able to. I don't think I'm going to be able to go to sleep. Not with a telescope that's up and running and the sky is beautiful. No way. I just won't be able to do it. I'll have to stay up.
What it is.
I know it. Check our all sky. What do we got? Okay. This is the all sky. Here's the observatory dome. Okay, this is the house. This is the camera setup. And, of course, this is the all sky camera. That's the Milky Way. In our sky, that's the Milky Way. And we know that Cassiopeia is rising over here. And we have Perseus is over here and rising. We saw the stars before, so I think not seeing the stars, I'm not sure why. Maybe it could be glare from these lights. But I will find out. These are all lights on my property. I have to turn them off. Okay. Let's see what we've got. I see clouds, but 4 seconds at 5,000 ISO. Okay.
Can I complain about lights a little bit?
Yeah.
The neighbor just to my south, I went around with him about some very bright lights he put on the front of his house. This isn't the hottest neighborhood, and his brother, I think it was, who was parked out front, got his truck stolen one night. And they've had other break-ins in their vehicles. I finally prevailed upon the guy to one of the lights was shining directly on my house, and I mean, it was just blazing bright. And I got the guy to shield that light so it didn't impinge on my property, at least on my house or out front where I usually observe. And that was all well and good. He was nice about it. But they were doing some gardening out in their yard on the north side, which faces directly toward my house. And they were growing tomatoes, shall we say. And the brother built a little greenhouse to shelter these tomatoes. And I guess they got concerned enough. These things are getting so big that he had a security light out on the north side of the house, but it was pointed down. It's not really a problem. Plus, it's a motion sensor light. And I guess he's so worried about his tomatoes, shall we say, that he put another light up, and it is aimed directly at my house. And when that thing lights up, it just blasts my house. You know, it casts really strong shadows. I was out last night, in fact, and looking for Perseids, and one of them walked through the backyard and set that light off, and it lit up my house like a drive-in movie screen. Really disgusting. I'm gonna have to go talk to them again.
Yeah.
But they're very impressive-looking tomato plants, I gotta say.
I think we all got the impression that they're not really tomatoes, Daryl.
Okay.
It's really rhubarb.
Just saying, you know.
Yeah.
It's legal here anyway, so.
Mm-hmm.
But all the same, you know, nobody wants somebody stealing their tomatoes.
Exactly. So I want to take a moment to say hey to Martian Johansson, who's here. How you doing? Thanks for coming here and checking us out. Normally we do these deep sky views from inside the observatory. The observatory, of course, is here in the all sky view, and usually the camera's attached to the telescope in here, and that research grade instrument is actually what we use to examine the sky and so forth. However, we do have a second observatory going in Arizona. I was supposed to leave this Saturday to go do that, and again, because of COVID, for the fourth time, I'm putting it off until the end of September. So I'm not happy about it, but you know what? It's nobody's fault. It's just unfortunate. Yeah. So we'll have two observatories. We'll have SkyTour LiveStream East, this one, and SkyTour LiveStream West. So West, I've had to write a observatory control program to run the observatory in all the aspects of the observatory. And it's not going to be a domed building like this one here. In fact, this building's going to get converted to an exact same type of setup as the one in Arizona, so that the software can run both of them, maybe even at the same time. I got some interesting plans for doing some binocular views from across the country of distant objects. The moon, primarily, because no one's ever taken a 3D image of the moon, but we're going to do it. We will be able to show you the moon in 3D. So, yeah, that's going to be cool. Whether the red and blue glasses or the other glasses that do this. It'll be pretty cool.
It'd be interesting to try the ones where, I forget what they're called. It's not the red and blue paired images. It's they'll have it looks like
shutter.
Two almost identical images next to each other, and you sort of look in between and cross your eyes, and
oh yeah,
the 3D image will pop out right in between the two.
Yeah, that's a manual way of actually doing it. To do if you have a stereoscopic set of imagery, you can do that. But you know that's tiring on the eyes.
It is.
Yeah, but I do it. and it actually is pretty neat, you know. But
Yeah, it produces an excellent 3D image when you get it to work.
yeah, yeah. And then what we do is we actually can do like at the studio where I work with Douglas Trumbull, you know, famous Academy Award-winning visual effects guy. There's a process up there that I had a small part in working through with Doug. You know, his main idea, and we actually create 3D movies at 120 frames per second in full beautiful 4K. Oh, there goes one. Did you see that? This one right here went right there. So our first one of the night.
All right.
Meteor. Yeah, we caught one. Yay. And when was that? I think it was... Was that another one right there?
Oh, there's something.
I think we saw another one over there. That might have been a sporadic.
Yeah. Not a Perseid.
Right. Well, not bad. I'm liking it so far. Let's check our all sky and see what it shows us. We have to wait for this exposure to finish, because it's on this exposure coming up. We'll go back and wait until that's over.
Quota Man said it showed up in bills too.
Cool.
I've wondered about that. You know, it's like if you're in Connecticut and I'm in Colorado, I am not going to see the same meteors you do. But you know, for a sense of scale and
Yeah.
size and whatever, and you know, your visible horizons and all that.
Theoretically, Bill's meteors could show up here if you do the triangulation and the angle between his and our locations, the curvature of the Earth. It is around the curve of the Earth for him too, but at the distance of the meteor, which might be like 90 miles or more. If it comes from the same radiant for him as for us, then for one of us it's going to be a much lower in the sky event. You know? Oh, thanks for defining a sporadic for them. Brainiest Belky. Hello, cousin. Unless the Earth is flat. Mm-hmm. That's right. Yeah, Martian. The one that was over here looked like what we call a sporadic, which the radiant for the Perseids is over here, right? And it's possible that you'll see most of them coming kind of in this direction. Right, this one here went like this over here, so that might be a sporadic, meaning it's like some space dust that we just happen to collide with. You know.
Yeah.
And then, so Cassiopeia is up here now.
You know, you want to see a good example of what we were talking about there, where, you know, like what you're seeing compared to what Bill's seeing, because you're relatively close together, but how it might change somewhat depending on your location.
Yeah.
When there are bright fireball reports, you'll read about them in the newspaper maybe, or, you know, online nowadays, and this is how they can help locate where a possible meteorite may have fallen, is by the direction people saw the meteor moving from their location. And if you read up all that information, you know, how high, how fast, what direction, from, say, southern Colorado versus northern Colorado or Wyoming or New Mexico, they can kind of triangulate in on where the meteor was heading and where a possible meteorite would have fallen.
Yeah. Actually, what I want... Go ahead, I'm sorry.
I'm sorry, go ahead.
I was going to say I want to add a meteorite radio to our arsenal as well, so we can actually hear the meteorites. Have you heard of the meteor radios?
I've heard of them. I've never heard one.
Yeah. When a meteor comes in, it's entering the atmosphere, and the molecules are being affected by this very high-speed object that's very hot, moving through the molecules. And what happens is some of the energy that's getting absorbed and scattered from these molecules is going to go into the radio frequency range, which are longer wavelengths. And you can hear this on these radios. You may remember AM radios during lightning storms. You hear, you hear static. Well, at a smaller scale, that static will sound like a whine, like a something like that. And the meteor radios will pick up this whine, and you'll actually see the whine, or hear the whine rather on this radio. Very cool and very interesting. And so I want to add that so that if we see a meteor, we can hear it at the same time. Won't that be cool?
I have heard of some people. You were talking about hearing meteors, bolide earlier.
Yeah.
And usually, you hear them sometime after you see it, because, like the rule of thumb about how far away lightning is by how many seconds it takes to hear the thunder, the old 5-second mile rule. You might see a meteor and then you might hear it a minute later. Some people hear an electrostatic sound instantly because it's traveling at the speed of light, I guess. They will hear something instantly when they see some meteors. This is sort of like the old Lucille Ball. I don't know if you ever heard this story. I Love Lucy.
Yes.
She claimed she could hear stuff like that through the fillings in her teeth, that she could hear radio and stuff in her fillings. And,
yeah.
Some people can actually pick up on this electrostatic noise, and they hear a little zip sound or something
Yep.
Instantly when they see some meteors.
That's very cool.
Yeah. What I was saying a minute ago about where you see a meteor pass in the sky can help people collecting data on it. By your location, wherever you are, they can triangulate and locate a possible fall location, fall site, or search ellipse it's called. I think it was November of 1982. I was out observing one night, and some drunk miners I knew in Leadville had come up to my place and implored me to break out the telescope. So I did, and we're standing out in the dark, and only one person at a time can look through the telescope. And it was late in the evening, sometime in November, I think. Made the newspaper. This meteor did. One person has been over the telescope looking through it, and the rest of us are standing around in the dark talking. And this tremendous meteor, a fireball, came out of the south, and it was headed sort of northeast. And just an excellent meteor.
Yeah.
And it passed behind the hill to my east and disappeared from view. And everybody went crazy about it. And I started making phone calls. Local police and area police, and the locals knew nothing. County sheriff in the county I was at, Lake County, Colorado, I forget, they might have had one report. Wasn't much information. And then I called Park County Sheriff's Department, which was the county to the east of us, which is the direction the meteor disappeared, behind the hill. And he had several reports. And then it occurred to me, I called the night desk at the newspaper in Denver, and said, hey, we saw a meteor, do you have any other reports of it? The reporter on duty, he just flipped out. He goes, yeah, wow, man, all over the state, all over New Mexico and Wyoming too. Tell me what you saw. Where was it? And I asked them not to use my name, but they used it anyway in the news story the next morning in the newspaper about the meteor. I wasn't looking for glory or anything. I was just curious. And, they said that depending on where you were, they saw the meteor in different parts of the sky moving different directions. But it all seemed to fall where a possible strewn field would have been in Park County. This is South Park for those who watch the TV show, the cartoon show, and it was it was near the town of Evergreen, if I remember correctly, in Park County. And one guy said he saw it hit the ground. And he said it was about the size of a 5-gallon bucket. And that's the last I ever heard. I don't know if they ever actually found anything or not. But I got off the telephone and I told the North Miners about this. And yeah, man, wow, let's go find it, Let's jump in the car at 2 o'clock in the morning and drive over to South Park and
One way to get rid of them.
Yeah. They really got wired up, though. Everybody was really excited about it. It was super cool to see, too. Just blazing bright meteor.
Like I said, there's a few things, about meteors which are really interesting. And this is sort of a conundrum not conundrum, but a little puzzle for those of you listening. If you're looking up and you see a meteor come in, what happens? What's it look like if it comes directly at you? For those in the chat, think about this. The meteor is coming directly at you, as seen from your position on the Earth. In other words, it's heading with all of its energy toward you on the ground. The meteor is going to look not like a streak in the sky, right? It's going to look like a brightening star that goes out after a second, or not even a split second. So it's going to go and then be gone. And you'll say, what was that? Well, how many times do you remember looking up into the sky and just seeing a flash? Just like a flash. Like a random flashing star. What was that star flashing for? What was that? A flashing star? What's that? You might have been seeing a meteor coming directly at you. Now, it doesn't mean it's going to hit you, because it could be coming anywhere within 10 or 15 miles of you, and it will look like it's coming straight at you, and you'll see the trail is all condensed into that one spot that you're looking at in the sky, and it will just come at you, burn out, flare out, and then it's gone.
When I saw those Roman candle meteors coming out of the sickle in Leo,
yeah,
the sickle was just rising back in '98, I think. What was really interesting, I guess it might have had something with the radiant point just rising above the horizon, but a lot of these things, the whole thing was staying inside the sickle. And as you described, sort of like a firework coming at you, the smoke trail and all that, or watching the thing, you could see it moving a little randomly, just a little bit. It's coming toward you, but it was, it'd wander a little this way and a little that way, maybe wind or air currents or something.
Sure.
But that was the one thing that reminded me of Roman candles, just that it was coming almost straight at me.
Yeah.
Tremendous to see.
Yeah, it's really kind of unnerving too. And I've seen some other things too, which I actually cannot explain. I looked up into the sky and I saw this bright dot, and I thought, what's that? I pull out my chart. I look at the chart. There's nothing there. So I didn't know what I was looking at. And then all of a sudden, maybe after about literally 60 seconds, I look back at the chart, I look up for it, and it's gone. I have no idea what I'm looking at. What the heck just came through here? What was that? Now, what it could have been was, it could have been a satellite, but I would have not. I didn't take a photo. Had I taken a photo, maybe I could have seen it moving slowly in the sky. Maybe this was an iridium flasher, because those satellites that actually flare after a time. Maybe it was an iridium flasher that actually had gone through this flare. But I don't know, and I really, to this day, I don't know. It was odd.
Yeah.
It was really strange, and I had no idea what it was.
I remember when the iridiums were still visible and active.
Yeah.
I could well imagine if you weren't aware of them, and you just happened to catch one happen, and you weren't looking at it closely, you'd say, "Wow, what was that?"
Yeah.
I got to get good enough with those. All you really needed was an accurate timepiece and a sense of direction, and
Yep.
I'll say how big your hand is, in the sky, that you could get a really good idea of where to watch that predictions said they were going to happen.
Yep.
And I got pretty good at going out and hunting the things down. I'd be ready before they ever happened. And I could often see the satellite moving before the flare.
Yeah. Yep.
It just looked like a run-of-the-mill, pretty faint satellite. It's sitting there slowly pacing along, and then you'd see that thing start getting brighter and brighter and brighter, and the flare would happen. And some of the iridiums were painfully bright, like magnitude -9.
I had just finished hosting a Mars party here at SkyTour LiveStream East, and I had like 30 cars driving down the driveway. They're all leaving. As the last car left, I stretched and I looked up, and 2 iridiums, and again, the iridiums are very bright satellites that were very reflective, and if they catch the sun just right, then that glare might pass over you. And the glare is, of course, a direct reflection of the sun, and depending on how much of the satellite is reflecting, the flare could be brighter or fainter. So I had 2 of these over my head, like 2 headlights in the sky, and they were so bright that it was painful to look at.
Yep.
And so I looked down at the ground, and I could see 2 shadows of my body on the ground from the 2 satellites, and they was slowly moving across the ground as the satellites were moving. I looked back up as they faded out, one first, then the other, and I was like, wow. And the last car had just turned out of the driveway, so all these people never got to see this amazing highlight of the night. We had been looking at Mars on the in the observatory on the front lawn for several hours because it was a Mars party. We had Mars balls, which were these little cheese puffs that were round, and it was really kind of cool. People enjoyed it.
Yeah.
Yeah.
Martian, Johansson, they have been decommissioned. There is a new generation of iridium sats. They do not do the flares. The old classic iridiums that did do the flares, they've all been decommissioned now. I guess they're being deorbited or whatever. But no more iridium flares, which is sort of a pity.
Yeah.
They were really cool, and all you needed was an accurate timepiece and some idea of where to look in the sky, and they were actually pretty easy to catch.
Yeah, I used to catch them all the time.
And as you said, the ones that are brightest, again, they got to about magnitude -9. Venus, which is brilliant in the sky, is magnitude -4 or so. And so what are you talking? 5 magnitudes brighter? That would be 2.5 to the 5th power or something like that times brighter.
2.512.
Yeah. They're like knitting needles in the eyes at their brightest, and they're almost painful to watch.
Yeah, very, very bright. No, I'm not trying to tell you I'm a Martian. At least, not, if I tell you, I'll have to, what you have to do if you find out something you're not supposed to know. We'll have to kill you. That kind of thing.
Ack, 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 ack. Ack, ack, ack.
Yes.
There you go.
Funny movie.
Martian, yes. Magnitude logarithmic.
Yes.
What is it? Fifth root, sixth root of 100?
Yeah, every magnitude is 2.512 times brighter than the other, fainter than the other, go the other way. So you can figure out the brightness that way. It's actually pretty cool. And when we look at the brightness of stars and everything, the sun's like what, minus 26.
Yeah.
The moon is minus 12 something. And so you look at the star. The moon is minus 12, but it's also half a degree in size. So it's pretty big in the sky. Make that a pinpoint in the sky, like an iridium satellite, right, at minus 9. And that's painful to look at. If you focused all the moon's light down into a tiny point, that would be too bright for the human eye to look at without being in pain. So that's why. I was going to say before, we were talking about lightning. I know that on some of the other streams tonight, like Bill's stream, there was some lightning showing up at one point. And it's interesting to note that when I was working on a mountaintop, I had, as I mentioned earlier, I had done in an observatory, I did parallax studies with a 20-inch refractor. It's a huge refractor made in the 1800s and really worth millions. It's a beautiful, beautiful machine.
Was it an Alvin Clark?
It was an Alvin Clark, yes, indeed.
Wow.
Yeah.
Lucky you.
Yeah. And it was so big that the whole floor of the observatory moved up and down to meet the telescope. And this was a floor that was about 40 feet across. So the entire floor was this giant elevator. When you started this elevator, you had to grab this big handle and go, and all of a sudden, and the whole floor goes up. And it's a big wooden floor. So it was actually really interesting. I need to move the control panel around. It was a gigantic control panel on wheels. Things have been altered a little bit since then, but remarkably, it's still pretty much the same. Well, anyway, the telescope is really, really big and beautiful, and so after I finished the parallax study, I went on to teach astronomy and to do gifted programs for folks. And I was on the mountaintop at this new place I was working at, a science center. I was the only real astronomer, as they called me there, because I got my degree in astronomy, and this is what we look like as real astronomers. Hello. And while there was a thunderstorm coming in, and I should have taken the hint when our weatherman left the mountain, saying this thunderstorm looked like it was going to be bad. And he said, "I'm leaving. You should probably leave the mountain." He says that these clouds are going to envelop the mountain, and you're going to be inside the storm. So there may not be very many safe spaces up here. And we're like, come on, these buildings have been here for 50 years. He goes, yeah. He goes, and you're going to have to pay the consequences if you're not out of here. I stayed, and didn't take much stock in it. And of course, he was absolutely right. And I set up the camera to take pictures of the thunderheads, because as they were approaching us, they were level with my camera because we're high in the mountain. They were actually, the base of the thunderheads were level. Really dramatic looking to see the base of these clouds coming towards you. So I started taking pictures, and I realized I got to get my camera closer to the edge of this precipice, this cliff edge, okay? And so I did, and I took more pictures, and then I noticed I was itchy. I was feeling itchy, so I started scratching my back and scratching my head. My head's itchy, and I realized, and I feel my hair out here, and it's like, it's sticking out. And I'm patting it going, ooh, wow, this is weird. I feel like, I'm a balloon, and I had like people were rubbing me, and that's. I have a dreaming dog behind me. I have my dingoes behind me on the floor, so the storm came in, and as it did, it was trying to send down electrical charges from the clouds, and the ground charges were trying to go up through whatever tall objects they were on the ground, because that's how lightning works. It doesn't go from the cloud down to the ground. It starts a little teaser channel from up on top, comes down, and charges rise from the ground, and they kind of meet in the middle. And when they say, "Oh, hi there," and they shake hands and say, "Okay, great," and they retreat and come, bam, and they come back through that channel they just made. They're called macro tortoise channels, the top of my head was one of these channels, and I realized right at the last second that this was dangerous. And I thought Marty had the right idea when he left the mountain. And I bolted for my office door. And I grabbed my office door. I left my camera on the tripod. And I got to the office door 25 feet away, which was I had to walk onto some asphalt at the time. I was on ground, the top of the mountain dirt at that other point by the edge. I went on the asphalt walkway, grabbed the handle of my door, just as I heard a high-pitched whine and the weirdest sound I've ever heard in my life, which might have been a combination of me saying something, or or uttering something, or the sound of the lightning striking the camera. But it was like a noise, and then that in my head. And as I grabbed the knob, I got a shock like I could not believe it. It was a massive shock. So basically, of course, it was a metal doorknob, and I was a grounded entity. And when I grabbed the metal doorknob, charges tried to race through my feet up through my right arm into the door. And they succeeded. And I managed to open the door because I couldn't let go of the door when that happened. And so I pulled the door open. And I got in my office, and the door shut behind me, and the power went out, of course, and I'm sitting there in the dark now. It's a high-pitched whine in my head, and I couldn't move my right arm, and it was vibrating uncontrollably. So what happened was I got nailed by the ground current from this lightning strike. The lightning struck the camera, went down the tripod, went into the ground, traveled through the ground as far as it could go. The asphalt walkway effectively stopped most of it. But what little got through got to me. And probably through the bedrock that the lightning charges were traveling through, that the building was mounted in. When I grabbed the door handle, I completed the circuit. And it was like, and wow, I saw lights in my vision, heard these high-pitched noises, and I like that weird noise. And then I was in my office, wondering what the heck happened, and saying, boy, let's go try that again. No, I didn't.
Listen,
you know what it's like.
I live in Colorado. The Rocky Mountains are here. And one rule of thumb is if you're climbing a mountain, you want to be off the top by noon. Because like the summer monsoon I was talking about earlier, the storms start forming and build in the afternoons, and a lot of people get hit by lightning up here. And you usually hear about one or two or three dying every summer.
Yeah.
Some friends and I climbed the highest mountain in the state.
Okay.
Mount Elbert, right outside Leadville. It's 14,400 some odd feet tall.
Okay.
High. And we were above timberline, and as often is the case, the clouds started forming below us, and we were up in clear air, but the higher we got, well, the clouds were building below us and started rising until they were above us. And it was getting pretty dicey way up high. We stopped maybe 50 feet below the top of the mountain. A woman in the group got scared and wouldn't go any farther, and I stayed with her to, make sure she was okay. And the other two guys completed the journey to the very top of the peak. And as you said, their hair was standing up on their heads and their beards were sticking out and all this
Yeah.
crazy stuff. And
Big signal.
yep. And I had a whistle punk whistle with me from working at the mine, and I started blowing that whistle to try to get their attention to come on down so we could get the heck out of there.
Yeah.
And they finally did, and the lightning started striking the peak of the mountain and all around us. And we ran off that mountaintop. And, I mean, that was scary. Lightning was just hitting everywhere all around us, above timberline.
And the lightning was going, "Get away from me! Get away from me! Never come back!" You know. Yeah. No. That's actually a couple close calls I've had with lightning. Oddly, the second one was with this long iron rod that I had put into the ground and held onto during a thunderstorm. No, I didn't. That was not true. I'm crazy, but not that crazy.
Ben Franklin could do it. You could.
Yeah, but you know, and I'm not sure if that's kind of a mythical event.
Yeah.
We're waiting for clouds, obviously. I know that people are saying, well, these are the clouds Bill had earlier. His clouds are actually a different batch. Mine might be, this is to you, Dalai, and others. Mine might be more permanent for the night. In looking at the weather in here, I can see that this might be a problem, but I'm going to take another 4-second or 1.5 second shot. Yeah, look at, see, we got this. This is now a denser location.
Solid deck of clouds.
Yeah, I got to be careful here because I don't often do this, but I actually have the camera out in the open. We can still see some stars through this light deck. And there's no rain at this point. Oh, man. Didn't we want to see the Perseids tonight?
Oh, yeah.
Yeah.
Mark, would you excuse me for a moment, please?
You know what? Sure, I will.
All right. Be
Go
right
for
back.
it. All right. Yeah, I'm looking over at Bill's too, and he's clear, but I'm like socked in with clouds. I don't get it. We are something of an anomaly. I'll tell you one thing though. When we get to Arizona, this doesn't happen out there. Oh no. We're gonna have clear skies for 300 days a year. So I hope you guys understand. Those that are new, welcome to the family. Those that are old hats here, we'll keep on trucking. And I can tell you, we're gonna definitely be looking at a lot of new things. You know, I took a picture of certain nebulae out there that over here you have to spend a lot of time and processing power to bring them out, tease them out of the background. Out there, you can almost see them with your eye. It was like I didn't want to stop taking pictures. I didn't want to stop. You know? Just like, oh, it's just beautiful out there. You know? Absolutely. Yes, I'm in Connecticut, Martian. Northwestern Connecticut, so that's why we have Milky Way up here. But not a lot of Milky Way compared to Arizona. Arizona, we've got a lot better sky. So we're looking forward to that. Oh, are we ever? So let's see. Okay, so... Alright, so I'm just going to wait here for a bit. Yeah. Carol, you're funny. Carol Carl says, Mark, just 1,000 more, Antonio. Yeah, I'm that guy that says, you know, wait, just one more object, just one more. Usually it's the people in the audience that say, you know, can you just do one more? Can you just do one more? Just tell us another thing. Just one more. Take us with one more object. Instead, that's me doing that. I just want one more. I'm going to do one more. And the people are saying, go to bed already. And it's like, no, just one more. And our streams that are going to be just 2 hours end up being 5 hours long sometimes. We just did a 5-hour stream not too long ago. Just, was it last week? I got going. I didn't want to stop. I just kept going, you know. And the way I've actually stopped doing that is by getting up earlier. And I get up at 8 a.m. now. And by getting up at 8 a.m., I end up being more tired by the time, 11:30 rolls around. And I feel like I have to end up going to bed. But I don't really want to if I'm on this run right here with the beautiful Persian meteor shower. See, that's a clear spot, right? So we can wait for a clear spot. Yay. Something's happening. Yeah. So we'll just wait and see. Next, let's look at the all sky. That's all it is a clear spot. This is the horizon. This is a 180-degree camera. And as I mentioned earlier, this is one that's going to be set up at SkyTour LiveStream West in Arizona, out in the Sonoran Desert. It's going to be set up so that it'll be able to see the full view of the horizon in all directions. And we will have a good record of the night sky. We'll see what's coming all night long. Now, in SkyTour West, most of the sky out there is going to be absolutely gorgeous and dark, like this has been. But one particular horizon, the east one, it has the sky glow from a distant city of Phoenix that's 65 miles away. And it's going to look about as bright as this does here, up to about here. But then from here up and over all the way down, it is stunningly black. And yeah, I'll tell you right up front, when you look at the sky out there for the first time, you will probably be speechless, and you'll just stare at the sky, and then realize I forgot to breathe, and you got to keep forcing yourself to breathe. You see more stars than you ever thought possible. Now, I've seen dark sky. I mean, as an astronomer, I've traveled to dark skies all over the place, but I can tell you one thing. The Arizona sky is somewhat unique. Where else in the world can you view, well, there's a lot of places, but view the winter constellation of Orion in a t-shirt and shorts? You know, it's beautiful. You know, the doll eye says it looks pretty clear, yeah. But look, it's not. Okay, there's some clouds that don't show up fully on the weather maps, and in this particular case, we got some here. You know, I'll just take a 1.5 second shot. Hey, Daryl, you're back, I see.
Yes, sir.
Yeah, this is what we got now. It's not looking too good.
I had to go out and look at my sky while I was away, and it's there are some clouds, but there are some stars visible.
Mm-hmm.
I don't know. Hopefully, it'll improve over the evening here.
Yeah. Well, look, you know, if you can't win if you don't play, right? And so what we do is we do this. We try to get some views. I know that last January there was a lunar eclipse. I think you were with us, Daryl, for the lunar eclipse.
When we saw the impact?
Yeah. And
I was there.
And right at the height of the lunar eclipse, where the moon was reddish down in its lower left quadrant, right at the height of that eclipse, all 5,000 of our concurrent viewers saw a meteor strike the moon. And we were one of only 5 groups on the planet that caught it. Yep. I mean, at least went public with it anyway. I mean,
I remember it well.
Yeah. And, you know, you think that the universe is static, the moon is done getting hit with things. It's not true. The moon gets hit every day, all the time. But most of the impacts are small and minor. We don't catch them if they're on the far side. And if they're even on the near side, we might not see them. If it happens during the lunar day, so to speak, we might not see it. Now, the Lunar Reconnaissance Orbiter circles the moon, and it takes photos from 60 miles up at its highest and 30 miles up at its lowest. Thanks to that, we can see the tire tracks from the lunar rovers and the experiments themselves, the ALSEP and the FLAG. We can actually see those from lunar orbit because we're not constrained with an atmosphere. The Lunar Reconnaissance Orbiter can fly very low over the area and take these breathtaking photos. And they are breathtaking. So I think it's really interesting when we look at an object like the moon and we then see that it's really still dynamic. There's still things going on there. And those things that are going on, of course, are impacts. And when you see one happen, then you're like, whoa, now that is amazing. And a lot of people were just stupefied by this thing. And I mean, that's a meteor, right? And because there's no atmosphere on the moon, it gets to strike the moon. And you see that. So, really fascinating.
If I remember right, we missed it at the time, but people in chat started talking about an impact.
Oh, yeah.
And you went back and reviewed the video and found the frame that caught the impact.
That's right. And it's on our site. These are all recorded. Look, a star. I see a star. Yeah. I saw the flash, but I didn't know. I thought it might have been just a camera sensor glitch, because that happens sometimes. Because it was fast.
Cosmic ray.
Yeah, well, yeah, and it just went. It was a flash.
Yeah.
And that was from a meteor that was 2 feet across, striking the moon at a few thousand kilometers per hour. And that made it end up vaporizing. And when it does that, it creates light. It converts the kinetic energy, the energy of motion, into the only thing it can when it strikes, and that's heat. Because energy is neither created nor destroyed. The conservation of energy dictates that it'll get converted from one type to another, and the energy it gets converted to is heat energy. Yep.
Yeah, I felt privileged to be a little part of that.
Yeah, it was great. I want to say hi to Rachel, who's joined us tonight. Thank you, Rachel, for coming out. Nice to see you again.
You know, something I need to do sometime, you mentioned the 20-inch Clark refractor.
Yes.
Earlier. There is one here. It's at the Chamberlain Observatory up in Denver.
Yeah.
It's operated by the University of Denver.
Yeah.
It is also an Alvin Clark refractor, and it's another 20-incher.
Wow.
I have never been there, and I've always kicked myself for that, because they do public nights up there occasionally.
Yeah. You gotta check that out.
That's one thing I should put on my bucket list, is go up and see that sometime.
Hello, Eva Glenn. Do the impacts on the moon, she asked, do the impacts on the moon affect its orbit around the Earth, as in conservation of momentum? Well, to answer the question, the impacts on the moon could affect the moon's orbit if they were large enough. But now we're looking at the behemoth versus the tiny flea, okay? When you look at impactors on the moon, they have to be extremely fast-moving and extremely large to make a significant impact on the orbit. And we don't see anything like that now. We saw things like that in the past, sure. And it was very clear that these things could strike the moon at very high speed. And it was very, very obvious that these things would affect the moon's orbit and its facing and so forth. But they're very, very big. They have to be massive impactors. In the same way that the impactor that struck the Earth to create the moon in the first place, by our best guess theory, was about the size of Mars, and it struck the Earth and caused the moon and other pieces of debris to blow out of the early young molten Earth, and those made probably a temporary ring around the Earth, and it ended up coalescing back into an object that became our moon. Now, just to give you an idea about mass in our solar system and where the distribution is of it, if you were to take all the asteroids, or the whole asteroid belt, remember the asteroid belt is, beyond Mercury, Venus, Earth, and Mars, and before Jupiter. So there's asteroids out there. That's the primary asteroid belt. There's a whole bunch of other asteroids. There's the NEOs, the near-Earth objects. There's the Trojan asteroids and so forth. We have scattered disk objects, which are objects a little farther out from the asteroids that are in highly elliptical orbits that could come closer to the Earth in some cases, and may. But if you add up all the mass of the asteroid belt, our primary asteroid belt, you would be surprised, thinking in your head, well, what is that, like a planet-sized thing? No. What those add up to mass-wise would be an object that's only about a fourth of the size of our moon.
Fourth the mass or a fourth the diameter?
No, fourth the mass. Okay. Fourth the mass of our moon. So basically, it's really not a whole lot of mass. It's just a lot of very small objects. So that's a very interesting factoid about the asteroid belt. And we're talking about meteors tonight, and that's why I've got this meteor here. This is from an Argentinian fall, and I mentioned it earlier.
Campo di Cielo?
Yeah, Campo di Cielo, yep.
Yeah. The French have a phrase. I don't speak French, so I don't remember how it goes, but it means thought of while bicycling home.
Uh-huh.
That rang a bell in my head earlier. I'm surprised it came to me, though.
And that was the bell on your bicycle. Ching, 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 ching. Yeah.
I used to be good at Jeopardy. I couldn't even do the senior tournament now. I think of the answers about a half hour later.
Yeah, I'm not. I've never been good at that stuff. I don't know why. I want to show you guys this while we're here again. I showed you earlier, but there's some new faces. This is a chunk of the Campo di Cielo Argentinian meteorite that fell. It was collected. I got it. It was given to me by a guy that wanted some other stuff from me, and so I basically traded him this, I call it an asteroid, this meteor for the work he wanted me to do. So it turns out this is just about 1,016 grams, so it's got some good heft to it. But you see these little odd shapes to it, all these ablation scars, all right, these objects here, your thumbprints, okay, these are all things that make these meteors more valuable because of their shape and the way they look. Some meteors are smooth, some meteors have this really interesting shape, and the meteor dealers will actually charge more for this guy than they would for a similar weighted one. They go by mass, that's just all smooth. And I've watched them do it. I didn't have to buy this one, but I am convinced that a meteor like this would probably, last I checked, this one was worth about $1,000 the last I checked. And that was from a meteor collector who looked at it. I don't know if it's valid, but you know what? I don't hold on to it for its value. I hold on to it because of what it is. This is a piece of a rock from space. This is iron from the sky. And they're the most common kind. Yep. Stony meteorites are more valuable. Chondrites are more valuable.
Some meteorites. I'd love to get a palisite. I have a tiny little chip
Palisite,
off
yeah.
a palisite. Those are probably the most beautiful of meteorites. They are, what are they? Olivine crystals in a nickel iron matrix.
Yeah.
And when those things are polished, they are absolutely beautiful. They look like jewels set in shiny metal.
Yeah.
There's a place out in Kansas that had a huge palisite fall, and they actually, I forget the name of the town. They had a museum or display built around this thing.
Yeah.
Locals went out and dug it up.
Yeah.
Ones like pallasites are really expensive.
Yeah.
They're relatively rare, and
Thinly
you want to
sliced.
see
They're full
really
of
rare
colors.
meteorites. I'm sorry.
Thinly sliced. They're full of colors. They look beautiful.
Yes,
Reds
they're
and
beautiful.
greens and blues. That's just stunning.
There are some lunar meteorites here on Earth
Yeah.
where an impact on the moon actually blew chunks out into space and eventually wound up falling to Earth here. Those are, I would guess, pretty much priceless. And there are very few Martian meteorites on Earth where something hit Mars and blew chunks out into space and they wound up falling here. Those are literally priceless.
Yeah, they are. Yeah. And now, you wonder, like, just to give you an idea, I think we brought back about a total of 800 pounds of moon rocks from the Apollo missions. And they're being curated at this one laboratory. And the laboratory is basically a bunch of the people that are there all day long. All they do is they take samples out of the special containers, and they take small pieces off of these samples to send to various other places for study. Okay, so it's actually a really interesting location because it is the one place that handles all the moon rocks.
The local Air Force Base here, Peterson Air Force Base, they have a small museum on base.
Yeah.
And I visited it once years and years ago. They actually had a small Apollo moon rock on display there.
Wow.
Tiny little thing. It was neat to see.
Yeah, they probably got it from these curators here.
Right.
Yeah. And you can they'll basically they'll hand you, they'll let you take a meteor or a lunar rock. If you're an accredited institution, you can take one because it's your tax dollars that paid for the missions. But you can only take them for a period of time, like a library book. And for heaven's sake, don't lose it, because you'll be paying hundreds of thousands of dollars in fines, right? I mean, it's, they got to prevent this stuff from being wiped off the face of the earth, right? Hello there, Jennifer T. Nice to see you. Welcome to SkyTour LiveStream. Anybody else has questions, let me know. Happy to answer them because we've got nothing to do right now with the clouds. Let's check our all-sky camera. I was really hoping to have a nice movie of our meteor night. Well, I mean, tonight's not the only night. I mean, if it's clear tomorrow, we can do it tomorrow too. A day or two on either side, you still have meteors. So.
I don't think I've ever seen you at a loss for words before, Mark.
I know. I'm looking at the sky, and then I'm actually looking at a few other stats here. And Martian, thanks, man. I think this is your first visit, yeah? But thank you for coming out, man. I really appreciate you coming, Martian. Thank you so much. And your donation, I'm humbled. Thank you. Very happy to have you with us. Oh, look, I see stars.
I see a star.
I know. Yeah, it's tough. Mind Remote 7, how are you? Mind Remote. Oh, yeah, no, I've actually talked about the moon ring like your question. He says, have you talked about the moon ring like a bell? Yes, as a matter of fact, the moon ringing like a bell, people often say, bells are hollow, therefore the moon is hollow. Unfortunately, that line of thinking kind of falls apart, though, with the moon, because seismicity studies on the moon show that the core of the moon may be molten in the very, very center, but the outer core, unlike the Earth, is actually solid. And the mantle of the moon is not like a plasticky molten material like on Earth. It's also solid. The moon has had time to cool, in other words, and the Earth will be there eventually. So, but the point being, the ringing like a bell has to do more with the fact that the moon is more solid throughout than hollow. The reason bells actually work is because they're open at one end, and you're setting up what's called a standing wave in that opening, and that's why they ring. You're hearing a standing wave, but an actual, like if you tap on a gourd that's been hollowed out, what do you hear? Thunk. You don't hear wah 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 wah. You just hear bunk. You hear this solid dull thunk, and that's it. You don't hear echoes. So, if you look at the moon, you're really listening to the sound of solidity and rigidity in the moon. On the Earth, when we send seismic pulses down into the Earth, they bounce all over the place. And based on the nature of the echo, we can tell what's there. And that's how we determined that the outer core is molten, the inner core is solid, and that the mantle is a plasticky, malleable, molten rock. And so we don't get nearly the same type of seismic responses that we do on the moon. Okay? And to prove this, there's a place in Pennsylvania that you can go. It's called Ringing Rocks State Park. And Ringing Rocks State Park is a place you can go with a hammer. And you walk in and you bang on the rocks and they go bing, and they ring in the same way that the moon rings, and for the same reason, because they're solid. And that's the process that causes the moon to ring. Just remember, bells ring because, and saying they ring like a bell is misleading. All right, bells ring because they're open at one end. The moon's not open at one end, so if it was hollow, we would just hear thunk, like a hollowed out gourd. When you tap it, it doesn't ring. So you see the analogy? So that's what that's about. But anyway, I think that those are all good questions. If you got more, let me know. I mean, after all, it's not like I've got anything to do right now. Carol and Tara, welcoming Tara back. That's very kind of you, Carol. Well, I say this, the SkyTour LiveStream audience is probably one of the best groups I've ever done anything for. And I'm very pleased that you are with us. So, I have to get another glass of water here. Let me look at the weather and see what we're going to be up against here. Then I'll get some water. And I'll let you take over for a couple minutes, Daryl. Okay, weather. Weather doesn't look good. Yeah, this. Okay, let me look at the. Oh. Okay, we have some good-sized thunderstorms heading for us.
Uh-oh.
Yeah.
Don't let the camera get wet.
Oh, I can't. Yeah, you're right. They're not here yet, but we're actually gonna probably get them before Bill gets them, but maybe around the same time. And he's lucky he doesn't have any real clouds there yet. No.
Go get you a drink, Mark.
Yeah, I will. Okay, I'll be right back, guys.
Okay. Blimey, he just vanished. He must have teleported to the water. Thank you, Boom Shakalaka. The best direction to look to see the meteor shower up, maybe face the northeast, at least early in the evening. The radiant will be rising over the course of the night and the morning, and probably the radiant will be closer to overhead by morning, a little bit north of overhead. But they say as a general thing, look maybe 30, 45 degrees away from the radiant. You may want to get where you have a good view, whatever direction you face, you have a good open look at the sky, and maybe park the radiant just in the corner of one eye, off to the side, and then just try to take in as much sky as possible. Open yourself up and relax. Don't focus too much on any one area. Just, lay back and relax and think of England, and try to take in as much sky as you can, and be relaxed and observant, and you may be surprised what you see. The moon is going to be a bit of a problem once it rises. We're at about last quarter now, so it should be rising roughly at 1 a.m. local time with daylight savings time. Any other memorable moments while watching the sky? I often talk about the peak year of the Leonid shower, which I always want to say was in 2000, but reports say it was 2001. That's what I get for not keeping observing logs. The radiant rose at midnight, and there were thousands of meteors an hour. Everywhere you looked, there were meteors constantly in the sky. And a little later in the evening, 2:30 in the morning, when the radiant was high up in the southeast, it was just like seeing the Starship Enterprise on warp speed, where the stars were or the screensaver on Windows, that meteors were just streaming out of the radiant constantly. It was beautiful. It was amazing to see.
Boom shakalaka. Shakalaka. Did you answer his question? by any chance?
I answered somebody's question.
Okay. What's the best direction to look to see the meteor shower? Thank you so much for that donation. Very much. Thank you.
I answered that.
You're going to look toward the northeast right now. And, that's about the right direction for the radiant. We're waiting for skies to potentially clear, but I actually don't think that, based on the weather, it doesn't look good for us. This happens sometimes. This happens sometimes. No fun, but that's the way it goes. So what I'll do is, because our skies look like they're not gonna clear, we are all for one and one for all on this streaming. So you might want to head over to Bill New York Skywatcher stream. His skies are clear in Newburgh, New York right now, and then we will see what happens for tomorrow night. But unfortunately, it just doesn't look like we're getting. Looks like we're not going to get a clear spot tonight. Let me try one more shot here. Yeah.
Them's the breaks.
That is. It's the way it works. It was clear early on. I'm also going to work on... my camera does 4K output as well. And I'm using a different technique to bring you the imagery, because we do this... we do the deep sky views. And so the way I bring you the deep sky views, it's really beautiful that way. But it's not the best for the meteor showers. But I think that tomorrow what I'm going to do is I'm going to try to get my 4K card back into the computer and see if I can try some HDMI direct output again and get it to work that way again. We'll see what happens. But anyway, you guys have a good night. I am sorry for the streams. It's like, I was looking so forward to seeing this, but maybe I'll head over to Bill's for a little while and hang out there as well. So I guess we'll see you over there, huh? So thank you for coming. Thank you, Daryl, for coming.
Oh, sure. Thanks, everybody. Have a good night.
Thank you all.
I'll probably see you at Bill's here in a little while.
I will be over there. We're heading to the other party, guys. So come on over there. Our party may be over, but their party is just beginning. See you in a few minutes, guys, and we'll talk to you later.